Hello viewers, today we start the lecture on eccentric connections. Now, first of all, we learn eccentric connection. If the line of action of the load does not pass through the center of gravity of group of bolts, the connection is known as eccentric connections. Again, must read down the line. If the line of action of the load does not pass through the center of gravity of the bolts, the connection is known as eccentric connection. There are two types of eccentric connection. First one is the line of action of load is in the plane of group of bolts as shown in figure first. There is load P and this is CG of the bolt group. The line of action of load is in the plane of group of bolts. In the connection shown in figure first, the bolts are subjected to shear force, direct shear force and shear force developed to resist movement P into E, where E is known as eccentricity. Of connection is line of action of eccentric load is in the plane perpendicular to the plane of group of bolts. You see the figure. Second, the load is perpendicular to the plane of group of bolts. This is second type of connection. In this connection, the bolts are subjected to direct shear and tension in bolts developed to resist movement. Now we start with first type of connection, that is combined shear and movement in plane. Consider an eccentric connection carrying a load P as shown in figure third. The basic assumption in the analysis are deformation of plates elements are negligible. Second one is assumption the total shear is assumed to be shared equally by all bolts. And third one is the equivalent moment at the geometric center of the bolt group causes shear in any bolt proportional to the distance of the bolt from the point O acting perpendicular to the line joining the bolt center to the point O. RMI is the force generated to resist the movement. So there is inclined force P as shown in figure third, resolving the applied force P into its components Px and Py in x and y direction respectively. Now the direct shear components in x direction is Rxi equals to Px upon N, and in y direction is Ry equals to Py upon N, where N is the total number of bolts in the bolt groups. Now the moment of force about the center of the bolt group is given by M equals to Px into y plus Py into x. X and y denote the coordinates of the point of application of force P with respect to point O. The force in the bolt I denoted by RMI due to the moment M is proportional to the its distance from point O and perpendicular to it. Then RMI equal to KRI, and where K is constant of proportionality, and here RMI is the moment of force about point O is Mi equals. Therefore, the total moment of resistance of the bolt group is given by summation of KRI square. Hence, from this equation we obtain K equals to M upon Ri square, which gives RMI, force on the ith bolt due to movement. This is equals to MRI upon summation of Ri square. The total shear force in the bolt is the vector sum of Rx, Rxi, Ryi and Rmi. And total shear force Ri is equal to Px upon N plus My upon summation of Ri square whole square and whole square of Py upon N plus Mxi upon summation of Ri square. And their under root will give the total shear force in the bolt Ri. Now we take one numerical. A bracket plate bolted to a vertical column is loaded as shown in figure. In M20 bolts of grade 4.6 are used. Determine the maximum value of factor load P which can be carried safely. Px equals to 0, Py equals to P. Total eccentricity E, that means x equals to 250 millimeter. For M20 bolts of grade 4.6, nominal diameter is 20 millimeter, whole diameter is 22 millimeter, and ultimate stress in bolt material is 400 Newton per millimeter square, where the ultimate stress for rolled steel sections is 410 Newton per mm square. The thickness of web is equals to 7.6 mm. Figure number 3rd. For ISMC 300, the web thickness is 7.6 millimeter, and this bracket plate is connected to the web plate, web of ISMC 300. Now, first of all, we calculate the design strength of bolt in shear. While calculating the design strength of bolt in shear, we considering the one of the plane of shear is touched at the threaded portion of the bolt. That's why design strength of bolt in shear is Fu upon root 3 gamma mb into 0.78 into pi by 4 into 20 square, which is comes out to be 45272 Newton. Now again we calculate strength in bearing against 7.6 mm web of ISMC 300. The formula is 2.5 kb T into D into Fu upon gamma mb, where kb is taken as least of the following: E upon 3d naught, E is basically 150 minus 60 because the width of web is 300 and its half is 150 minus then 60 is given as shown in figure upon 3 into 22. kb is 63. Second case, P upon 3 do not minus 0.25, pitch is given as shown in figure 80 millimeter. Therefore, kb from second consideration is comes out to be 0.962. Hence, the least value from all these, the kb is 0.962. Therefore, design strength of bolt in bearing is given as 2.5 into 0.962 into 20 into 7.6 millimeter is the thickness of the web multiplied by 410 upon 1.25. There is 119919 Newton. Hence, design strength of bolt is 45,272 Newton. Now, as you see in figure number 4, the bolt which is far away from the center of gravity of the bolt group has carrying the maximum force. That means the radial distance of bolt 1, bolt 2, bolt 3 and bolt 4. We have to calculate. If radial distance say R1 is greater than all the radial distance, then the maximum force will develop at bolt number 1. In present case, all the distances are equal. So the maximum force in extreme bolt is equals to direct shear force plus force due to bending moment. Direct shear force, total force is P divided by number of bolts is give the direct shear force 0.2 P. In present case, the radial distance from CG of the bolt groups of the extreme group are all equal. There is R1 equals to R2 equals to R3 equals to R4. 80 square plus 60 square, under root of 80 square plus 60 square, which is comes out to be 100 millimeter, and the radial distance of fifth group from the CG of bolt group is equals to 0. Hence, summation of R square is 40,000. Now, force due to bending moment in extreme bolt equals to P into E into R1 upon summation of R square. It is equals to 0.625 P. Angle between these forces is theta. Therefore, tan theta equals to 60 upon 80 and theta equals to 36.87. Now, as shown in figure 5b, we have to calculate resultant force of F1 and F2. So we get resultant force Fr, which is equals to 0.2 P whole square plus whole square of 0.625 P plus 2 into 0.2 P into 0.625 P into cos 36.87. The resultant force is 0.7941 P. Basically, the force developed in bolt first due to load P is 0.7941 P. This force 0.7941 P force should not be greater than bolt strength. Hence, equating the bolt strength equals to 0.7941 P. Therefore, we get P equals to. Now, you must also perform these exercises which are in this exercise. There is multiple choice questions. The first one is, when the axis of load lies in the plane of bolt group, then the bolts are subjected to. In this case, the correct option is A. When the axis of load lies in the plane of bolt group, then the bolts are subjected to only shear stress. Now we come to question number second. When the bolts are subjected to reversal of stress, the most suitable type of bolt is high strength bolt. We must perform this exercise. And in next lecture, we solve the remaining numericals on first type and second type of eccentric connections.